Let's solve a word break problem today from LeetCode. It's a medium level problem. Let's try to understand this problem, and then we'll find a few different approach to solve this problem. So the word break problem is here. Like if you see there's a word LeetCode, and in a word dictionary there are a few other words, and we want to check like this word exist here in a manner like we can break this string successfully. Like if I see the leet, then yeah, leet is exist here, and then from here we can break, and from here that's, you can say that's a one break point. So leet, so this leet exists here, and from here again the code that also exists, and then string ends. So in that way we can say that okay, that's true, we can return true because successfully we can break this word based on this word dictionary. So that's the one example. Another example, you can see apple. There are two words in a dictionary, and this apple exists here, apple. And after that again, if I take this pen, the pen also exists, and again there is a apple, and that apple also exists here. And in this way we can break this string here and here and here. So we can return true in this case. Let's analyze another string here. In this case, if you take example cats, so okay, I can take the cats here, and from here I see any word from this dictionary exists here, and there is an and, so I can take and. After that og, so there is no og, so we cannot break this string. Let's try with cat. There is a cat here, so I can try with a cat, and there is another string sand, so I say nd sand here, and again og, so og is not in this dictionary, so here we can return false. So there are multiple ways to solve this. We try in a few ways. So for now, the strategy I'm going to use is from here, I will take there will be a loop, and the for loop, we can just use the for loop here. In the for loop I can take some word here, and so take this word like leet word. So from here I just iterate and take this L, take EET leet, and I'll check here in this dictionary whether that leet exists in the dictionary or not. So if it exists there, then we can change our string. So this string is LeetCode, so that when this exists, then what I do, I'll again run another recursion, and in the new recursion, new string will be just code, and again from this code we'll take this code and we'll check the code exists in the dictionary or not, and if it exists, then we'll also run another recursion, and in this case the code is out from that main string, so that's empty, and if it is empty, then we can return true. So the third level of recursion, true, it will come back true, and then finally we found the word, and that means at the end there will be empty string. So that's the logic I'm going to use. So our base condition is when we iterate from here to end, and if the string is empty, then that's the base case or exit condition. So let's do that. So for the word break, I'm going to use a helper function. and we can pass as a string, and then also word dictionary. So word dictionary, I want to make it as a map, so I can say words map string, and just I want to store the string and the value will be just empty struct. So that's the words here, and that's all we need. So for this, let's put this word dictionary in a map first. So I'll create a map, then it's a map of string and then empty struct. I will iterate through these words. Word dictionary. So from this area I will get the word one by one, and I can put that in a m. So m, the key will be word itself and the value will be empty struct. Yeah, I can put anything here in this value because I'm not going to make any use of that value. That's why I just putting this empty struct. So our dictionary is ready, and we can call this function word breaks, and this name is helper. Yes, and you can pass words that dictionary, that's a m. I can pass m, and that's the words here. Okay, and it's going to return the boolean. So our base condition we found, if this s length is, if length of s is equal to 0, so in that case return true, because we reach at the end, and that means we are finding that each word, and that's what we are moving normally. So that's why we can return true here. Okay, that's good. Now we'll check. Okay, so we can check in a different way this word. So how will you check this? So maybe we can iterate from here. So let's have one for loop and check. Like the for loop, I can say I is equal to 1 and I less than length of s and I plus plus. So so I can start with the 0 to I, then in that way I'll get the L. Again I will move to 2, then I can take the LE, then I can take LEE, then I can take LETT and check whether it's matching. Is that word is in our dictionary or not. So I'll just say substring, and here I can say s from 0 to I. So first time I is 1, so 0 to I means I will get the L. Next time I will keep increasing, I will get LE, I will get LE, I will get LEET. So once LEET is, if SS, I will check if SS exists in this words map or not. So I will check here, okay, and I just words, and in this words I'll check SS, if the SS exists there or not. Okay, and if exists, if it exists, that's word exists, so that means Leet exists. So in that case I want to make another recursion and I want to check if the code exists or not. Okay, so I will call this word break helper again, and in this time my string, we already found the Leet, so that means my new string will be code. Okay, so in the new string we'll start from here. So that means from here, new string, I can say new, or I can put it here, new string. So new string will be from the SS. I want to start from the, so we found the leet, so that means we found the first word. So ss will be length of, I can say ss, because the leet we found that, so length of ss, or we can, yeah, that's the length of ss. Yeah, so we found the here. So from this place to end, so that's new word. So new word will contain just code. So that's a new word. I'll put the new word here. I mean new string, I can say, or we can say new string here. It's better, new string. And we can pass the words. Good. And in this way again it finds code. So in the similar way, you know, it will come back here, and the new string is the code. I is equal to 1, so it will start from j is there is no j, but 0 to I, so 0 to c, 0 to I is 1 to c. Some again I will increment, and then we'll get the co, then we'll get cod, and then we'll get code. Okay, we found that, and then again we'll call the again word break helper third times, and where our new string will be empty, because after this there is nothing, and this will return true. So I can check if this returns true, then I can return true here, and at the end, so return false. Let's try to run this. Check for any syntax error. Wrong answer. Why? Cat's dog. Output true. Okay, in this case this should return false. At least it passed this one true, passed this one, but it's not, it didn't pass here. Let's check again. Length is, if this is 0, true, the base condition is good. I is 1, increment, oh, so we have to make it s, because at the end when it goes, so when it extract, it will go like we have to give 1 character extra. So let me run this time again. So I can check with, it's returning true. Why? I less than length, I plus plus, that's good. And then we'll get ss, that is from 0 to I. We'll get 1 word, and then we'll check that word ss exists there or not. And if it, so if it exists, the new string, so new string will be length of, so this is from s, our original string is s. From s we are getting from length of ss. Okay, good. Submit this. Time limit exceed. Yeah, so in this example, you know, like let's say a, we're checking for the a, so we are not we can use the memoization here. Like for this, what I can do, when we find, you know, the some solution, and next time you can use the same solution, because already we can exist, you know, so we know the memoization. So for that, let me send, or let me create another map here, map, or I can say the dp, so make the map, and a map, I can put I can store a string itself. So for the string, and what it's going to return, boolean. If it is there, then either true or false, return boolean. So I'll pass this dp here, or I can say, yeah, dp, that's fine. So dp make map of string, and then boolean. And when we find result, at least we find a word. If a word exists, then we come here, and before returning true, I can say dp, that whatever the string, whatever we string, for that string we found, so dp is, and I can make it true, and if we do not find, then I can say dp whatever the string was there, that's will make false. Okay, and in this case I can also check if we find the result, if our value okay and then dp string, if that exists, then return v itself. So that's the change memoization we have to do. And let me run first. Okay, we need to pass that dp here. Accepted. Okay, yeah, so that's the one way of doing this problem. Yeah, that's all for now. Thank you.